Okay, so AB is parallel to DC, and they're called the bases. These other sides are called the legs. So the leg angles are the angles that touch the leg. Here's a leg. Leg. Here's another leg. D and A both touch the same leg. They add up to 180. So what does that mean? Also, I changed that, so make sure you change that. It should say D, but it says B. So fix that. So like if you are looking for angle D, you know that A and D add to 180. It says it right there, and that's always the case. So like if you're looking with the bases on the top and the bottom, the two parallel sides, which is like the normal way to look at a trapezoid, the top and the bottom angle on each side will add to 180. Okay, what does that look like? That means angle A is 65. So 65 plus... Okay. And then you just subtract. So you don't have to write this out every time. I'm just showing you what's happening. So 180 minus 65. And then 115 is what angle D equals. All right, so I have solved for D. I want you to solve for angle C. You know that angle B is 42. So solve for angle C. Okay, so they add 180, you subtract 180 minus 42, you get 138, great. So hopefully we have the idea of what's going on. I wanted to show you a few extra pictures just to make sure you know what is happening, because this is a weird looking trapezoid. I mean, look at it. Does that look like a trapezoid? Okay, I mean, if it does to you, great. To me, I'm like, oh, that's a weird shape. But it is a trapezoid. There's one pair of parallel sides. And over here, this looks like a lot more like a trapezoid. But these two angles are going to equal 180. You just have to remember what the box stands for, which most of you guys do. That's typically not an issue. But the box stands for 90. So 180 minus 90 will equal 90. Therefore, angle Y is 90. That's pretty simple. Same idea here. We're just subtracting from 180 all day. So 180 minus 110 is 70 degrees, and that's what angle V is. And I know I went kind of quickly, but we're literally doing the same thing every time, and there's 4 different problems, so I don't feel like we need to dwell on this. These two are going to add to 180. This side and this side don't necessarily have a relationship for these types of trapezoids. These are just normal trapezoids, okay, where these are the two properties. It has exactly one pair of parallel sides, which are called the bases, and then the leg angles are supplementary. So we have covered that. Great. Now we're going to throw something else in there that has to do with trapezoids that's kind of off the rails as far as like properties. But if you put a median there, the median is going to be equal to, which this is the median, the mean of the bases. Who in here can tell me what the word mean means? Yeah, Shane. The average. That's fantastic. Would you like a dum-dum? Nice. All right, Janae still wants one. We'll see. I mean, it's a possibility. You're on the right track. So the mean is going to be the average. So all you're going to do is, and just think of like an average, which you guys know how to do the average, you just may not know that you know. Like, if you made an 80 and a 90 on 2 different tests, then what's your test average going to be? If you made 180 and 190. And 85. Yeah, it's just halfway in between. That's what an average is. Same idea here. Halfway in between. So 17 plus 47 divided by 2, which that can be put into your calculator. 17 plus 47. You get 64, except no one can see that. And then you divide that by 2, and, okay, that's not right. 64, you divide it by 2, and you get 32. Another thing you could do is put it in the calculator like this, 17 plus 47 divided by 2, and you would get that answer. I just hesitate to do that if it's an odd number, because it'll give you a fraction, but that's fine. But yeah, so you get 32. Okay, and then what if you don't have the two bases? We actually did this when we talked about midpoints, and this is the same idea where you got to figure out like how far is it from here to here. So like because it's halfway, 16 is halfway in between. So if we figure out the change from here to here, it's going to be the same change from here to here. So you start with 21 and you take away a certain amount, however many. And if you're like, I don't know how many I take away, here we go. 21 minus 16. That's 5 away. 21 is bigger than 16, so you obviously need to subtract. So minus 5. See that? And then you just do that again. You guys may recall this from when we did midpoints. We did something similar. If you don't, it's not a big deal. But you're going to do the same thing. You subtract 5 to get there, so then you take 16 and do the same thing. And you get 11. So that's pretty easy, I think. Let's go to the next page. And there's really just a few more things on this page that are important. Here is the main difference. We are now talking about isosceles trapezoids. So like specifically the word isosceles is different. You don't have to have highlighter. If you do, great, you can highlight it. Or you can just circle that so it kind of like brings it to the front of your attention, the fact that it is isosceles. It adds some different properties. So the difference with a normal trapezoid and an isosceles trapezoid is, first of all, the legs are congruent. So AB is the same as CD. And then secondly, these, you know how I said earlier, well, some of you might remember, if you do, great, how the sides don't necessarily have a relationship. It was just the top and bottom add up to 180. Well, in isosceles trapezoid, they do have a relationship. Like, these angles are going to be the same. The base angles are the ones that touch the bases are the same as each other. So like B will be the same as D. So honestly, I think this makes it a little easier than it was before, because these two are going to be the same. So what does that mean? Why does that make it easier? Well, let me show you on Q and R. So ultimately, you're looking for this and this. And every other time we had been dealing with this, it was always opposite angles are congruent, it's 110. That's not the case here. In this case, Q and R are the same because these are base angles. This is a base and this is a base. So the angles that touch that base are going to be the same. Therefore, they're both 110. Pretty easy, hopefully. Next, these still add to 180. Angles add to 180. All right, so 180 minus 110 is 70. So great, we found this angle, it's 70. We found this angle, it's 110. And since we know these, this is also going to be 70. This is a quadrilateral, and this makes sense because all 4 of these angles should add up to 360. We talked about this that last week, the sum of the interior angles. All right, that's great. And then this thing that I pointed out earlier, the fact that AB is equal to CD. So remember, geometry, the first semester of geometry is honestly just a lot of setting things equal and adding it up to equal 180. Well, we did the 180 thing. Now we got to set some stuff equal. These two legs are the same. 3x equals 12. Great. So if we divide by 3 on both sides, x is going to equal 4. And yeah, that's how you solve. If you're given 2 legs, set them equal to each other. All right, we just have a couple more. And the main reason I added these is because it's just ever so slightly more complicated, but it's the same idea. So the same idea that we did up here. If this angle is 110, this angle is 110. Same thing here. This is an isosceles trapezoid. If angle X is 110, angle W is also going to be the same thing. So it's 110. So just put an equal sign in between them. 110 equal sign 17x plus 8. Don't overcomplicate it. They're equal. Put an equal sign in between them. And then this is just a 2-step equation to solve. So minus 8 on both sides. 102 equals 17x. So I just took away that x, or that 8, because I want my x's to be all by themselves. And then my last step, 17 times x. So I need to get rid of that 17 because I ultimately want x to be all by itself, just stand alone. But in order to do that, I need to take 102 and divide it by 17. And I get 6, a nice, pretty whole number. All right, and then the last one. So here's where it gets confusing. And it's really not that confusing. It's the same thing. You're either setting things equal or adding things equal to 180. Here's the deal. You've got to be able to identify what are the bases and what are the legs. Here's my parallel sides. So these are the bases. So like these are going to be touching the same leg. So remember, legs are on the side, bases are parallel. So these are not equal to each other. You can also just like look at the picture. One angle is small, angle Q is small, angle R is big. They are not the same as each other. So like use like some common sense by just looking at it. I know sometimes you look at it and you're like, this is overwhelming, I don't know what to do. But look at this. These two angles, they both look like they could be the same. These two angles do not look like they could be the same at all. Okay? So we're going to add them together, and they're going to equal 180. Because remember, you only have two choices today. All right. Add those together, set them equal to 180. That's good. I'm glad. And then we're going to combine like terms. So 6 plus 8 is 14. So you've got 14 x's. And then you need to combine negative 22 and positive 34. Negative 22, positive 34 is 12. This really throws people off a lot when there's a negative and a positive. One takes away, one adds. 14x, we're going to subtract 12 on both sides. 180 minus 12 is 168. Oh, I can't. Right. And then our last step is to divide by 14. X is 12. And that's it for today.